There are two definitions of acids and bases that you should be familiar with, the Arrhenius definition and the Bronsted-Lowry definition. The Arrhenius definition states that an acid is a substance that when in water releases H+ ions into solution. HCl is an example of an Arrhenius acid. Two other examples of Arrhenius acids are nitric acid and acetic acid. Sodium hydroxide is an example of an Arrhenius base. An Arrhenius base is a substance that in water releases hydroxide ions into solution. Another Arrhenius base is potassium hydroxide. Though useful, the Arrhenius definition is just too narrow. For example, ammonia, NH3, is a base, but it doesn't have a hydroxide group. In addition, vaporous ammonia reacts with HCl vapor to produce a white cloud of solid ammonium chloride. So, acids and bases don't have to react in water. A Bronsted-Lowry acid is a substance that can donate a proton, and a Bronsted-Lowry base is a substance that can accept a proton. We call this proton H+ for a hydrogen atom stripped of its one electron. H+ and proton are used interchangeably when discussing acid-base chemistry. Let's take a closer look at the bottle reaction. When a molecule of HCl encounters a molecule of ammonia, a proton, H+, is transferred from HCl to ammonia, forming solid ammonium chloride. HCl is a Bronsted-Lowry acid because it donates a proton, and NH3 is a Bronsted-Lowry base because it accepts a proton. In aqueous solutions of acids or bases, water performs an interesting role. It can act as either an acid or a base. When HCl is dissolved in water, a proton is transferred from HCl to water, forming a hydronium ion and Cl-. In this case, water accepts a proton from HCl and is therefore a Bronsted-Lowry base. HCl, since it is donating a proton, is a Bronsted-Lowry acid. When ammonia is dissolved in water, a proton is transferred from water to ammonia, forming the hydroxide ion and the ammonium ion. Water is now acting as a Bronsted-Lowry acid because it is donating a proton, and ammonia is a Bronsted-Lowry base because it is accepting a proton. Because water can act as an acid and as a base, it is called an amphoteric substance.